Where I left off in the last video, we were saying, well, I have two dice, like, let's say we're playing Monopoly, two six-sided dice, and I want to say, what's the probability that I get a 7? So when I add up the two rolls on the dice, what's the probability I get 7? So I drew this grid here, and this grid essentially represents all of the outcomes I could get with the two dice. Where on the top row, that's the outcomes on dice 1. I could get a 1, a 2, a 3, a 4, a 5, or a 6. And similarly for dice 2, these are all the outcomes I could get. So each of these squares represent a particular outcome of both dice. For example, this square means that I got a 6 on dice 1 and a 6 on dice 2. Right? And of course, what does that mean that they added up to? They added up to 12. Right? And we could go through all of them. Essentially, we could take the sum of dice 1, dice 2, and we could say, well, what do they add up to? Well, this is 2. This is 3, 4, 5, 6, 7, and then this will be 3. It'll go up. Let's see. This will be 3. Then this will be 4, 5, 6, 7, 8. This will be. Let's do all of them. 4. It just keeps going up. 5, 6, 7, 8, 9. This will 4 plus 1. This is 5, 6, 7, 8, 9. 10, and I think you see a little interesting pattern here, right? Will be 6, 7, 8, 9, 10, 11, and this is 7, 8, 9, 10, 11, 12. So if I said, what's the probability of getting a 7? Well, that's all the squares that have a 7 in them. So let's see, let me see if I can use this fill tool. This could be interesting. So where are all the 7s? I have this one, this one, this one, this one, this one, and that one. So what's the probability that I get that? It actually turned out pretty neat how that worked. What's the probability of getting 7? Well, from our one of the original definitions of probability, we said, well, what are the total number of equally? Let me do it here. Probability of 7. What's the total number of equally probable outcomes? Well, we have 36 outcomes, and they're all equally probable, right? There's 36 total outcomes. And so what's the probability we get 7? How many of these 36 outcomes result in the dice adding up to 7? Well, it's 1, 2, 3, 4, 5, 6. So 6. So the probability of getting a 7 is equal to 6 over 36 is equal to 1/6. And so we could, use this grid is useful for figuring out the probability of getting any number. We could say, and we can even just by looking at this, we see that the most likely of all of the numbers we get is 7, right? And if you just look at the pattern, because it covers this whole diagonal in terms of, and then the probability of getting a 6 is equal to the probability of getting an 8. The probability of getting a 9 is equal to the probability of getting the 9 is equal to a probability of getting a 5, and so forth and so on. Actually, let's do that. Let's say so 7 is the most probable, and just to get some intuition on dice rolls, let's say what's the second light. So what's our probability of getting 8? So we have 8, 8, 8, 8, 8. And so how many 8s are there out of the total number? Let's see. So the probability of getting an 8 is equal to 1, 2, 3, 4, 5 is equal to 5 over 36. And that's also equal to the probability of getting a 6, right? 1, 2, 3, 4, 5 6s. Probability of getting a 6. So let me color the 6s. It's the same green, just so we know that that's a. So that's a 6, 6. So those are all the 6s. And this actually wouldn't hurt to memorize, because when you play Monopoly, you'll know your odds of landing on Boardwalk, for example, and then you would have to you would know what your. Well, actually, I'll probably do another video on what expected value and expected cost and things like that, because that's probability plus a little bit of money, and it'll be very useful when you're playing Monopoly. And so we could keep doing. What's the probability of a 5? Well, it's 1, 2, 3, 4. There's 4 out of the 36 outcomes are a 5. So the probability of a 5 is the 4 out of 36, and that is equal to 1 over 9. And that's also the same as the probability of getting a 9. Probability of 9 is equal to 1 over 9. So that's interesting. I mean, if you ever play craps or you play Monopoly, you now have a sense of what the different probabilities are of the different rolls. And, that's why I think in a lot of games, 7 is a very important roll, because that is actually the most probable of number. For example, the probability of getting a 7 is higher than the probability of getting a 9 or a 5, right? Because what's the probability of getting, what's the probability of a 5, and we'll say or a 9, that u is a or, right? Well, that's the probability of getting a 5 plus the probability of getting a 9, which is equal to 1/9 plus 1/9 plus 1/9, which is equal to 2/9. Oh, actually, I was wrong. You see, that's why it's good to do the calculation. 1/6 is less than 2/9. So no, this is a higher one. But I can say, so I was wrong about that. But we can say that the probability of getting a, let's say a 2 or an 11, 2 or an 11 is less than the probability of getting a 7. And let's calculate that. What's the probability of getting a 2? A 2, actually I should have said a 3 or 11. I wanted it to be symmetric. Well, let's just go with what I wrote. Probability of 2. There's only one situation where I get a 2, right? So this is 1 over 36. 1 out of 36 results in a 2. And then the 11, that's 2 out of 36, right? So 2 out of 36 is 1 over 8. Let me write it as 2. 2 out of 36. And so that equals 3 over 36. And so that equals 1 over 12. So the probability of getting a 2, which is just this one, or an 11, is 1 out of 12, while the probability of getting a, so the probability of getting a 7 is actually twice that of getting a 2 or an 11. So that's just interesting. I know, sometimes I don't know where these are going, but I think it's interesting to analyze dice because dice show up a lot. And another way, although this grid is probably the clearest way of doing it, another way that I do it, if I don't have a grid in front of me, if I say, what's the probability of getting a, I don't know, let's say, what's the probability of getting a 5? Well, it's the probability of, let's say this is dice 1. And this is essentially the same thing as a grid, but it's good to have multiple frameworks of this. So how can I get a 5? Well, if I get a 1 on dice 1, I get a 2, I get a 4 on dice 2. If I get a 2, then I need a 3. If I get a 3, then I need a 2. If I have a 4, then I need a 1. And then if I have a 5, no, and those are the only situations, right? So we could say, well, what's the probability of getting, so this, we need each of these probabilities, and then the next one has to be these. So there's 4 probabilities that kind of keep us in the game in dice 1. So what's the probability of getting a 1? Well, that's 1/6. So this is dice 1. This is, you get a 2, this is a 3, this is, you get a 4. Right? And so what's the probability of getting a 1 on dice 1? That's 1 over 6, right? And they're all 1 over 6. That's the probability you get a 2, that's the probability you get a 3, that's the probability you get a 4, right? And so, given that you got a 1 on dice 1, what's the probability you get a 4 then? So then, there's 6 this tree, and there's, you can get a 5 or a 6, but those don't count because we'd be out of the game. So in dice 1, then on dice 2, there's a 1 out of 6 chance that I get a 4. And then there's, a bunch of other chances for all the other numbers, but this is the only situation in which we get a 5, right? And similarly, on dice, this is dice 2, this column. And then if I get a 2, what do I need on dice 2? I need a 3. Well, to get exactly a 3, there's a 1/6 chance again. And of course, they sum up to 5. If I have a 3 here, then there's a 1/6 chance that I get a 2, which is exactly what I need. And of course, there's a lot of other things we can get, but we're selecting for the 5s. And if I had a 4, I'm going to switch colors. There's a 1/6 chance that I get a 1 to get a 5. Right? So what are all the probabilities of this? Well, this is 1/6 times 1. So the probability of this, of getting a 1 and then a 4. Let me clean this up. I think I'm running out of time. Actually, let me do it on this side. So the probability of this event, these are messier than normal, of this one, of getting a 1 and then getting a 4, well, that's 1 out of 36. Right? 1/6. This is 1/6 times 1/6. This is 1/6, and then after that happens, you have to get another 1/6. So that's 1 out of 36. And by a similar logic, this is 1 out of 36. This is 1 out of 36. And this is 1 out of 36. Each of these is 1 out of 36. And if you think about that grid we drew, each of these outcomes represent a square on that grid. Getting a 2 and then a 3, getting a 1 and then getting a 4. And then our total probability of getting 5 is the sum of all of these. 4 out of 36, which is equal to 1 over 9. So I just wanted to show you, you don't have to draw a grid. You could do a tree, you could do a little table like this and say, well, what are the ways I can get a 5 and what's the probability of each of these, and then sum them up. And they all work. And in different times, different methods will be more useful. I will see you in the next video.